Hello, welcome to Interaction Design Module 2 Tutorial 1. What are we going to be doing today? Well, we're in our week 5, our first tutorial of the new module, and we're going to be looking at P5. Specifically, we're going to be looking at P5 sound. And you may be wondering, what is P5 sound? If you've watched the lecture or you've already had your lecture, you might already have some explanation there. But just to expand on it or reiterate, P5 is the P5.js sound library. P5 sound doesn't come in the boilerplate version of P5. If you want to work with sound, you have to include the library, whether you download it and include it locally or whether you link to the URL for it. It allows P5.js to use web audio, and that's a pretty powerful tool. It is also a powerful design tool just for creating interactive generative projects that are mixing audio and video. We're going to be using P5 for our form storming. We have a series of tutorials each week that are going to deal with different parts of P5. This week, week 5, we have 3 separate video tutorials. This is the first one. We're going to be in each one looking at different aspects of P5 and exploring sound with P5. We're going to be looking at creating synthesized audio with P5. We're going to be looking at playing and controlling an audio file. And we're going to be looking at how we can access and analyze live audio using the microphone. Let's take a quick look at P5. If we go to the p5.js website, to find the sound library, we move into libraries, and you'll find it's the first one. So if we click on P5, you'll notice that there's a lot of options here, and it can be a little overwhelming at first. The purpose of these tutorials is to grab some of the really fun things so that you guys can get started right away. Let's take a look at some code. The code file, the first one that you guys are going to look at, is going to be called P5 Sound Synthesis. What you're going to want to do is pull P5 Sound Synthesis into Visual Studio Code, which is what I'm using. You might use Atom. You might be using Replit online. That would be fine as well. I would suggest if you're using brackets, it's time to upgrade. In the, in fact, if we open it up, you can actually see that inside there's an HTML and there are 3 JavaScript sketches. You can see those here. In our index, you can see that there's not too much going on. There's in the HTML, there's a little bit of CSS for the body. And you can see that in the canvas. Coming down into our source code, you can see that it's connecting to the Cloudflare p5.min.js, just spread this over, the p5.dom.min.js, and you can see here that it's added the p5.sound.min.js. This means that this is a very, very lightweight system. There are no libraries needed to actually download on a local machine. But you can see we're going to start off looking at the sketch.js. So let's take a look there. Right at the top, you can see that there's a link, or at least there's a URL here to go to a YouTube video. This is if you want to know more about what we're working on. The information here, a lot of it came out of some Dan Schiffman tutorials. If you don't know who Dan Schiffman is, he's one of the people that was a part of porting processing into P5. And so his tutorials and a lot of his code have made up a bunch of the examples that are actually on P5. So this one in particular is looking at how you can create synthesized sound. So if you wanted to watch that video to know more about it, you could. We're going to walk right through it here, though. And sometimes the code, in fact, not even sometimes, all of this code has been optimized, so it'll be different than the code from the YouTube video. Everything has been sort of updated to CS6 with the functions. There's some things that weren't working. What you'll find specifically when you're working with P5 sound, especially when you're uploading it to your server, one of the main concerns, not the only concern, but one of the main concerns is Chrome requires a user to make a gesture in the browser. So what does that look like? Well, it means that when you load for instance, if I load this page, which is actually this code right here, you see there's a button right in the middle. There's a dark, like a dark background, right? And specifically, if I did not have this button here, I would get an error if I went to try to play a frequency in the browser. And that's a security measure so that someone can't just go and start playing sounds in your browser without you giving permission. So in this case, permission means clicking the button. And if we do that, you can see that it will, and you can hear that it will play a tone. So specifically, let's take a look at how that's working. We have a couple of variables up at the top. We have let wave. Remember, these are just names, right? These names mean different things, but they're just names. So we have a let wave, we have a let button, and we have a let playing. So think about this for a second. We have a sound wave, and that's what this is. We have a button object, which is what this is. And we have a playing scenario where we need to have this, where we need it to do a thing. So these are our three variables. In our setup, we just have our create canvas, and then you can see that we have our button right here. And the button, you can see it's a create button. The play pause in the string is specifically what will create the name of your button. You can see that in the mouse pressed, button.mouse pressed, we are looking for a turn on function. And if I just scroll down, you can see that I have that turn on function right here, and we can take a look at that in a minute. But that's what that's doing. And then we have a button.position, and I have it set at 100 by 100. You can place it anywhere you want on the canvas. You will find that it certainly works a lot better if you don't give it an arbitrary number. It works better if you give it an absolute number. So you can certainly put it wherever you want on the canvas, but I would stick with just giving it an exact location, right? Which is easy enough if we can just sort of move it around where we want. Then you can see that we have called, so we have our wave variable here that we declared. We're now defining it, and we're defining it with a new p5.oscillator, right? And in the oscillator function, you can see that what we've given it is a sine string. And you might look at this and say, I don't know anything about this. I'd like to know more about it, or it confuses me. And of course, the very first thing we should do is always go right back to the P5 website. And on the P5 website, if we scroll down where we were with the P5 sound library, you'll find there's p5.oscillator. And if we go to oscillator, you'll find that there's an example here. The example is going to use a couple of its own variables, and specifically, and I don't know if this will, oh, there it is. And what I'm doing, I'm clicking, and as I'm clicking, you can hear that it's starting a tone and ending a tone. And in this function draw, it's doing exactly that part. You can see it's setting it to a map. I haven't looked specifically through this, but you will find that this frequency and amp are specific things that are going to come up when we're working with oscillators. So, and if you wanted to know more about specifically some of the syntax, you'd be able to come down. If we scroll down here, one thing to mention is that you're going to see that it talks about different kinds of sine waves. So there's triangle, sawtooth, and square, and of course the right here we have the sine, which is the sinusoidal shape, and that's the default one. We're still calling it in our string. To know more about these other ones, I would actually suggest you take a look at the YouTube video, because Dan really digs in about explaining the different waves in this one, and there's a video actually in the next tutorial that I linked to of his as well. So if you wanted to know more about the actual way that the waves function, I would actually suggest going right ahead and taking a closer look at his video. He'll explain it great. For us, what we should know is that you can see that you would have to actually name the different wave when you define it. Okay? So we have our wave that has been defined, and now if we look in draw, you can see that we have this if statement, and it's basically all of draw really is that one thing. If I just separate that a little bit, clean that up a tiny bit, you'll actually see that oh, you know what, actually that's a little better like that, because then this if statement goes there. So we have our if playing, which is going to be saying if playing means if playing is true. So if playing is true, and you might at that point ask, well, what is playing? And in fact, if we look down here at this turn on function, which just to remind you that the mouse pressed triggers the turn on function. So when you press the mouse, it will execute this function. So the turn on function, if we come down here, it says if not playing. If you see an exclamation like that before a word, it means not. So if not playing, then do the thing in the brackets, and in the brackets is playing equals true. So what's happening here is it's taking playing, the let playing here, and it's turning playing into a Boolean. And if you don't remember what a Boolean is, it's a true false statement, right? So it's setting playing to true, wave dot start. So it's starting the wave oscillator, okay? And this is specifically what happens if you click in the browser and it gives permission. Okay, so that is playing equals true, wave dot start, and then you'll notice the else. And the else is, which means that if else is if it is playing, and you click the turn on function, playing equals false, and wave dot stop. So this is what actually starts and stops the sound. Okay, the start and stop is right there. So this is a very mechanical kind of function that way. So coming back into the draw, we have our if-else statement here. And the if-else statement here is, so if playing, right? So if you've clicked the button, then change the background color to red, right? So we have 25500. So change it to red. And you can see that it's setting this wave.amp and wave.frequency. So remember that wave is just the name of the variable we gave. This could be any name. We've called it wave. Now amp is specific, and this is giving it the amplitude. And this is the frequency. This is specific. So the amp and the frequency are both specific things you can play with. You're talking about the volume, and you're talking about the frequency is going to be what creates these different sounds or the types of notes they are. And before we take a look at that, I'm just going to also point out that the else of this means that it's going to, if playing is true, then do this part, else do this. So we have these two if-else statements. And they're very, very similar, but the difference is that the draw is looping over and over again. And you're not allowed to put your wave.start in your draw, because then it would start without a user gesture. So in particular, this is how you give permission. So coming back to this wave.frequency, what I would want you guys to do is actually, other than, playing with different colors and buttons and stuff like that, because you can see very easily that you can come in here and do some button styling and change those types of things, right? But this is a good way of understanding also how different frequencies affect different sounds. So we're at 440. What happens if we do 600 here? Wow, right? So what if we try 1100? And with that, you can see how easy it is that P5 can go in and make specific sounds by altering the frequency. For our second one, we're going to take this exact sketch and we're going to play with it a little more. There's been a few changes here. Oh, you know what? Sorry, before I do that, let's go into the index, and I'm going to change this link to sketch 1. And you can already see that it made a big change there. Whoops. I need to go to sketch 1. Now, this, like I mentioned, is a different link, right? So please follow this link and take a look at the more sort of extensive explanation that Dan gives to wave functions. We still have our let wave, let button, let playing. That hasn't changed. We're in our setup. We still have our canvas of the same size. We in fact still have the exact same play pause button. Here's a thing that's different. So we've added a slider. So in this case, it's so slider equals create slider. You can see that what it's done is it almost works like a map function. I've given it a range from 100 to 1200, and it's going to start at 440 hertz frequency. And the slider position is set at 100 to 120, so it's just basically underneath the button. But again, you can place that wherever you want. Doesn't matter. I mean, for you guys, please explore it, have fun with it, try styling the sliders. Lots of different things you can do. In fact, we will look at styling buttons and sliders in a following tutorial. We're just not going to deal with it today. Again, you can see that we have our wave. None of that part has changed. Maybe I'll just separate that a little bit more. So now you can see that we have our button, our slider, and our wave. Now in our draw, things have kind of been reorganized a little bit. We still have our if playing. Now you can see that we still have actually the wave.amp has not changed. It's still a 0.5. The wave.frequency, however, you can see that instead of giving it a specific value, it's going to be drawing the value from the slider. So it's slider.value, and you can see the value is a function. So so it's a method because it's inside a function. So it has the double brackets there. If you don't put that there, it won't work, okay? And what that is going to do is it's going to attach the slider position to a frequency between 100 and 1200, but it's starting at 440. So that position there is at 440, and if we go lower, it would be at 100, and at the very top, it would be at 1200. And it doesn't matter, like if I put it there and I reset it, you can see it'll go back to 440. What else has changed? The only other thing that's changed is, in this case, I've simplified it so that there's no else statement in the draw, right? So now it's just if playing. And I've moved the background, right, into the turn on function. So now it will only turn red when you click it, and it will turn black when you click it again. Well, it turns red if the frequency is off. If the frequency is off and you click the button, it will then turn red and turn the frequency on. And if the frequency is on in the else statement and you click it, it will then make the background black. Now, if I made this background 0, then what would happen is this would stay white and would go from white to red. And you can see that if I turn that on, now it goes to black. So, I mean, that's a pretty basic thing, and we could put the background in the draw so that it would start as black, or we could come in here and make that white, and then when we click it, it would just go, oh, that's interesting. Oh, it's at 0, sorry. 255. Always remember that 255 is at the top. There we go. So now you can see that it's doing the same basic thing, except here's the added part is specifically now with the slider, we have another level of control. Okay, so this is just also showing you how you can add a slider. You can connect your slider to your frequency. So the idea here is you'll be able to go in and start playing with this. Let's take a look at our third sketch. and go to sketch 2. Oh, and there's a big change. Now, this sketch has come from a few places. Originally, there was actually a tutorial that Mark Shufflebottom had done that was using this sketch, but actually I would say it's also a sketch that comes right out of the p5.js website. Dan Schiffman, I believe, wrote this sketch. I'm gonna just, let me pull that up there so it's a little bit easier to see. I'm gonna fit the whole thing in our screen. There we go. Reset it. Now, it shouldn't start by itself, but it did start by itself, which is fine. But you can see that when we start it, it'll then start playing these notes. Reset it so it goes right back. So let's see how this is working here. This, I believe, is actually the first link. I haven't added a new link for this one. You can see that now we've got a couple of different things going on here, and I wanted to make sure there was showing you different ways of using buttons, because they don't all have to be the same way. Here we have our variable on that's created. We have a button variable. We have our let OS see instead of wave. But we have a couple other things. We have envelope, we have FFT, and you can see we've got this array, this scale array, and it's got a series of numbers running from like 60 up to 72. And then we have our let note, which is just another variable starting at 0. We've got our create canvas, and you can see that on is actually going to be a Boolean. So it's going to start as false. And you know what, I'll just make a little space there. Then you can see that we've got a button. This button is called start, which is right there. There's our string. Then we've got our button.position, which is just at 1919, which I mean, it could be anywhere you want. In this case, it's just put there. And our mouse pressed is still using a turn on function. In this case, we're running no stroke. And the no stroke, what that's going to do is it's going to allow for the red bars that are coming up are going to not have a line around them. And then you can see that it's actually calling that turn on function. And you know what? That was exactly where it was. So the reason why it was starting is the turn on function was going right away. And as I look at this, now I see there's a play button, but the play button is not set to I'm actually a little surprised that turn on function is right there instead of being on the inside. I'm a little curious actually if we just turn that off. Yep, that's fine. And if we and the draw should, you know what, if we take the background out of the if statement, I think that might be a little bit better. There we go. So it starts off black now instead of the black being only on the if statement, which means you have to click in order to start it. Great. Okay, good. So now as we're looking at that, so I've turned off the turn on, which means that it isn't going to turn on immediately, and you could see that especially that first time it did until I reset it. In our turn on function, you can see that we've set the variable, the variable on the Boolean to true. You can see that OSC, and instead of wave, we're calling it OSC, equals a new P5 oscillator sign. That's all the same. This is just reminding you to take a look at the YouTube video at the top so you can know more about the way that works. If you haven't already done that, I suggest you go and take a look at it so you understand more about the way the different wave functions work. Now, in particular, we're adding this specific new thing, which is an envelope, right? And this is what is going to make this a little more interesting and specific to this part of the tutorial. So let's pull up P5, but we want to look at P5.envelope, all right? And just to give you to point to it, sorry if I can just find the, there it is, P5.envelope. So I've already got it here, and if we look at it, what you'll see is that, so we've got a series of these variables that are just called T1, L1, T2, L2. You can see that in the comments we've got an attack time in seconds, attack level in seconds, a decay time in seconds, and a decay level in seconds. So what the envelope is doing is it actually allows you to take a series of these specifics. So the attack time and the attack level, the decay time and the decay level, and it allows you to take those, and you can see that it's in the envelope, in this new P5 envelope, it's taking each of those as a parameter. And so specifically, if you want to create an envelope of sound that's going to be a more nuanced, a more interesting, deeper, richer type of sound, this is a way of doing it. When you're talking about synthesized sound, of course, you're talking about taking things that are starting off very kind of 8-bit sound, and how do you enrich in that so that it's a much richer kind of sound, and it's using this envelope function that you can do that. So let's go back and take a look at what that means when you're using it. So you can see that we've got this, and when you see this set ADSR, specifically that's actually, if you look at this, a few things just to mention. So we have our ADSR is the attack, decay, sustain, release. Let's actually pull up that envelope again so we can kind of see the specific. So when we're looking at the OSC set frequency, there we have the sustain and release ADSR. You know what? Actually, I'm going to click on that so we can see, this gives us our attack, our decay, our sustain, and the release. It certainly seems to be that the decay has to have more to do with the way that when you the onset of the note, how it responds to the onset of the note when the key is pressed, before you're dealing with the sustain, which is the sort of duration, and then when you release the key. So this is specifically going to be when you release the key, how long does it take for the note to trail off, and that's going to be what the release time is. So I haven't done a very good job explaining decay time there. But you know what? I do know for a fact that Dan digs into it, and so hopefully you've watched his video and I'm just rambling, and you can listen to his and it'll make a lot more sense with that. So the envelope.asdr, though, you can see that the way these numbers are going to connect to those things, the ADSR, envelope set range. That was what I wanted to check, though, was the set range, so that we could see that. New envelope, release. Use set range to change the attack release level. Use ADSR to change attack time. Right, so it's setting it just to a 1 and a 0. So it's probably because we want to have it as a button. That's why. Right, because we want it to go from a 1 or a 0. Okay, so as we move down, we have our OSC start, right? Because remember that we are in this turn on function, so it's going to need to turn on that wave. And now FFT is a funny one. We're going to be dealing with FFT in our third tutorial, and specifically it's a frequency analyzer. And in this case, I'm not sure exactly what it's analyzing, but as we move down into the next one, we can take a look at it, because it will become clearer. But so just when you see that FFT variable as we go further down, watch for it. So also wanted to mention that the turn on function is very much about the sort of mechanical way that the audio is playing, right? And the draw is sort of the visual representation of that audio for the most part. Not always, but it's in many ways the way we're sort of handling it. So in this case, we have a slightly different if statement, and we have if on. So remember that this on is going to be that on equals true. So when you have an if statement with a function like this, it's actually treating it like if it doesn't have an exclamation, it means that if on equals true, then do this. And you can see I've got a bit of a note there for that. We have another if statement on the inside of that, and this if statement is going into using a frame count, and it's running into a MIDI, right? So it's creating a MIDI, it's calling it MIDI value, but remember this is just another variable name. So let MIDI value equals scale array note. It's taking this is also scale array, just calling it that, and it's putting this note as the array on the inside. And if we go up and take a look, we'd find that we have our scale array, and these are the specific notes that we're dealing with, right? We then have another variable being named here, just frequency value, frec value equals MIDI to frequency. This is going to be its own function that is definitely going to be just part of the sound library, and it's using that MIDI value as its value. And then it's turning on the wave function with frequency, and it's taking that frequency value and putting it in there. And I cannot explain to you exactly how this works. I'm just trying to kind of walk you through the mechanics of it. We have our envelope, which we've already looked at how the envelope works, and it's playing that, because you can see here with play what it's doing is it's using the source, so it's the wave, and it seems to be kind of mapping it from like 0 to 0.1. It's then, we have our note, which, did we call note at the top? Yes, we did. Let note equal 0, so note starts at 0, and then here so we've declared it there, and here we're defining it. So note equals, and it's note plus 1. So what this is actually doing is this is functioning like a for loop. So it's taking whatever the note is and it's adding 1 to it. What that means is it's going to take this array that we have further up here, it's going to take 60, add 1 to it. So that doesn't mean go to 61, it means go to the next one, right? So this, of course, is in an array. This is spot 0, 1, 2, 3, 4, 5, 6, 7, and so it's going to add 0 plus 1 is 1, 0 plus, 1 plus 1 is 2, and it's basically just going to move up the levels of the array like that. And it's going all the way to scale array.length. So this is exactly that. It's a very different way of writing a for loop. It's not one that I've seen very often, and maybe that's what's kind of interesting about it. Even the way it's using the percentage there, that's not something that I've really seen very much of. Here's where it talks about the FFT analyze in its frequency analysis on the canvas. So let spectrum, so that's interesting. It's creating a new variable called spectrum, and it's doing an FFT analyze. And here's a full for loop. So let I equal 0, I is less than spectrum.length. So it's every time it creates that, it's going to give it a full distance, right, or size, divided by 20, and then it's just counting. So from here to here, this is all within the for loop, all of these. So we see that there's a fill, and the fill is going to be giving a spectrum. So this is what's giving the red some specific color there. So let's pull that up, and here we'll be able to see when I start that. So you can see that there's that interesting range running from the red to the black, and that's what this is actually doing. So fill, of course, is looking for RGB. So this is the R is the spectrum I. So it's running this within a red, but it's funny that it's also, so this is the G, which is running it from, so it's the same intensity as this, but divided by 10. So it's much lighter, and then there's 0 of the B, right? So if we were to add something here, we could change the color there quite a bit as well. So that's interesting. So we've mapped it to the spectrum.length, and that's what's allowing the whole thing to kind of animate while it goes with the sort of range of black and red. And that seems to be what both of those are doing, except this one is mapping it by height. So let's take another look at that. You can see the decay, right? Like it's actually changing while it goes, and that's what's happening there. It's mapping that to the frequency very specifically. Fun. And then the rect is the shape, so that's why it's in that very long rectangular shape. And you can see that we've got the different, these are the 1, 2, 3, 4 different parameters for the rectangle. So we have x, which we've given x a specific size here, right? So let x, let h is going to be, so negative h, that's interesting. And the spectrum dot length divided by 20 and height. So it's going the full, it's potentially going the full height of the, and that's the range. So it's, and height in this case would mostly be starting from the bottom. The way that it counts down. So starting at the bottom, working up. And it could be, and I'm curious about that, whether the negative h is actually going to be the way that it declines each time when it changes, kind of fades out. So it's kind of interesting. That's the best explanation I can give for this. It's a pretty complex little arrangement, and my hope is what you're going to do actually for this first tutorial is you're going to go in and you're going to play with some of these numbers to kind of get used to them. Always make sure that you record the things you do and save them so you can work on them with your form storming. Make sure you do a lot of good documentation of it as well. So before we end this tutorial, let's actually pull up. So we've looked at the code. Let's kind of take a jump. So with your P5 sound form storming, what you're going to want to do is experiment with the code that way. I want you to go in and play with the mechanical way the code works. I want you to go in and play with the aesthetic way that the code looks. Definitely follow your curiosity, even if it breaks the code. Learn about the way it works. You can always go back and re-download this and save a version every time you hit that sort of aha moment. Make a lot of documentation, including the video documentation. And with that, why don't you go ahead and start form storming.